Welcome back to section 5.2.1. We're continuing on, except now we're going to be talking about solving absolute value inequalities. It's just like we did when we solved the quadratic. We're going to treat them as equations. So the absolute value of x plus 4 equals 6. We'll come back to the inequality in a moment. So we solve each part. We set equal to -6 and +6, our two equations. X plus 4 equals -6, x plus 4 equals +6. Subtract 4 from both sides, x equals -10. Subtract 4, x equals 2. So now here's where we come back to the inequality. On the number line, our -10 is over here. Our +2 is over here. We have a greater than or equal to, so we're going to use a solid dot. And now pick a test point in between, just like we did. Let's use x equals 0. Going back to the original, absolute value of 0 plus 4 greater than or equal to 6. 0 plus 4 is 4. Absolute value of 4 greater than or equal to 6. 4 is greater than or equal to 6. That is not true. It didn't work. If it's true, we shade in between. If it's false, we shade in opposite directions. So we would be shading on the outside. Now, think about that. If we picked a number less than -10, like -11, let's make that a -12. So you get the absolute value of -12 plus 4 greater than or equal to 6. -12 plus 4 is -8. The absolute value of -8 is 8, and that is greater than or equal to 6. That worked. If we pick a number greater than 2, maybe like x equals 5, for example, absolute value of 5 plus 4 is greater than or equal to 6. 5 plus 4 is 9. The absolute value of 9 is 9. Greater than or equal to 6, and that is also true. So we are going to be shading in those outside regions. It's an OR inequality. So the left-hand inequality, x less than or equal to -10, because it's a solid dot. And on the right-hand side, x is greater than or equal to +2. There's our solutions. Treat it like an equation. And then graph those points and use a test point in between. If it works, shade in between. If it doesn't work, shade on the outside regions. Treat it like an equation. Absolute value of 2x plus 1 equals 9. So 2x plus 1 equals -9. 2x plus 1 equals +9. Subtract 1. 2x equals -10. Divide both sides by 2. X equals -5. Subtract 1 from both sides. 2x equals 8. Divide both sides by 2. X equals 4. Plot on the number line. We got our -5 over here, +4 over here. We're going to use open dot this time because it's less than. And now pick a test point in between. 0 is in between, so we can use that. 2 times 0 plus 1, and we're back in the inequality, so less than. 2 times 0 is 0 plus 1. So it's the absolute value of 1 is less than 9. 1 is less than 9. That is a true statement, so we'll shade in between. This is an AND inequality. So x is in between. -5 on the left, +4 on the right, and we put our less than or equal to's in We just put a less than because it's an open dot. And there is our solutions. Those are all the values that make that inequality true. Number 9. Before we do anything, we have to isolate. Add 2 to both sides. 4, absolute value of x plus 1 is greater than 8. And then we can divide both sides by 4. The absolute value of x plus 1 is greater than 2. Now we go to the equation. The absolute value of x plus 1 equals 2. So x plus 1 equals negative 2. X plus 1 equals positive 2. So you get x equals negative 3. X equals 1. There's our endpoints. Negative 3 is over here. Positive 1 is over here. So now we want a test point in between. Test when x equals 0. Back into this inequality. We have, open dots there because it's just greater than. 0 plus 1, the absolute value of that is greater than 2. The absolute value of 1 is greater than 2. 1 is greater than 2. That is not a true statement. So our shading doesn't go in between. It goes in opposite directions on the left and on the right. So what we have is an OR inequality. So on the left-hand side, x is less than negative 3. On the right-hand side, x is greater than 1. And there's all of our values of x that would make the original inequality true. Problem number 10. Treat it as an equation. Absolute value of 7 minus x equals 4. So 7 minus x equals negative 4. 7 minus x equals positive 4. Subtract 7 from both sides. Negative x equals negative 11. Divide both sides by negative 1. X equals 11. Subtract 7 from both sides. Negative x equals negative 3. Divide both sides by negative 1. X equals 3. So now, on the number line, 3 is here, 11 is here. Now, we can't use 0 because it's not in between. So I'm going to pick any other point between 3 and 11. So let's try x equals 5. Absolute value of 7 minus 5 less than or equal to 4. 7 minus 5 is 2. Absolute value of 2 is less than or equal to 4. Now 2 is less than or equal to 4. That is a true statement. So we shade in between where the 4 was, or the 5 was. So now it's an end inequality. X is between 3 on the left, 11 on the right, and we use our less than or equal to's to complete that statement. Problem number 11, you want to isolate. So we're going to start by adding 5 to both sides. Absolute value of 1/3 x plus 4 is greater than 1. Treat it as an equation now. The absolute value of 1/3 x plus 4 equals 1. So 1/3 x plus 4 equals negative 1. 1/3 x plus 4 equals positive 1. So we can get rid of the fraction by multiplying everything by 3. 3 once, twice, 3 times. So we get x plus 12 equals negative 3. Subtract 12 from both sides. X equals negative 15. Multiply everything by 3 to get rid of the fraction. X plus 12 equals 3. Subtract 12 from both sides. X equals negative 9. Our number line now. Negative 15 would be on the left. Negative 9 on the right. Because it's a greater than, open dots. And a test point. We can't use 0 again. So let's test x equals, just going to pick a number, negative 12. Absolute value of 1/3 times negative 12 plus 4 greater than 1. Now I picked a number that was divisible by 3 just to make this a little bit easier. 1/3 times negative 12 is negative 4 plus 4 greater than 1. Negative 4 plus 4 is 0. The absolute value of 0 is greater than 1. 0 is greater than 1. That didn't work. So our solutions aren't in between. They're in opposite directions. So our solution would be an OR inequality. X is less than negative 15, or X is greater than negative 9. There's our there's our inequality, our OR inequality. For a problem like number 12, remember to isolate, divide both sides by 2 first. Absolute value of 4 minus 1/2 x less than or equal to 6. Treat it as an equation. 4 minus 1/2 x equals 6. So 4 minus 1/2 x equals negative 6. 4 minus 1/2 x equals positive 6. Get rid of the fraction, multiply everything by 2. 8 minus x equals negative 12. Subtract 8 from both sides, negative x equals negative 20. Divide both sides by negative 1, x equals 20. Multiply everything by 2 in the second equation to get rid of the fraction. 8 minus x equals 12. Subtract 8 from both sides, negative x equals 4. Divide both sides by negative 1, x equals negative 4. Our number line, negative 4 goes on the left, positive 20 goes on the right. It's less than or equal to, we're going to use solid dots here. Pick a test point in between. We can use 0 again, because that's between those two numbers. So we have the absolute value of 4 minus 1/2 times 0 less than or equal to 6. Negative 1/2 times 0 is 0. So 4 minus 0 is 4. Absolute value of 4 less than or equal to 6. 4 less than or equal to 6 is a true statement. We shade in between. So we have x in the middle, negative 4 on the left, 20 on the right, and we have less than or equal to's on both sides, and there are the solutions. Okay, next we'll talk about graphing, and I will see you in the next video.